Hello, I'm Gary Evans and I'm a product manager for the AMC Enterprise Solutions here at Rocket Software. In this video, I will walk you through a brief demonstration of how development containers can be used to provide a flexible, consistent and dynamic development environment for maintaining mainframe subsystem applications. The version control system is the cornerstone of any development environment, and never more so than when using development containers. Within the repo, we store the metadata and instructions that pertain to the building of the environment within the development container when it is initialized. Here it consists of the devcontainer.json file and a related Docker file. In this repo, we are also storing the infrastructure as code elements that will provision a full working version of the application that the developer can use to test the changes to the application in isolation before committing the changes to the CI/CD process. And finally, we have the actual application source code against which the changes will be made. In this case, I'll be using Visual Studio Code as my user interface to my development environment. So, let's get started by cloning the repository. I have VS Code connected to my WSL2 environment running on my Windows laptop, with no AMC Enterprise products installed. Obviously, I have to provide the appropriate credentials to give me access to the repo. As there is a devcontainer.json file inside my repo, VS Code prompts me to reopen the environment inside that dev container. Once inside the dev container, the process to provision my isolated development environment and build a full working copy of my application begins. As this is the first time we're using this environment, the provision can take a little while, but subsequently, only deltas can be applied. As the container ports can be forwarded to my host environment, I can use the browser on my laptop to view the running version of my application that I can use to develop and test. The port forwarding also gives me the ability to use the inbuilt browser-based 3270 emulator to interact with my application. We see here our standard demonstration application, BankDemo. Please pay special attention to the screen titles and the branding element on the last screen, because these are going to undergo some changes. Now I'll return to my dev container environment to make some actual changes to the code. I'm going to start with a change to the BMS. Next, I'm going to make a change to a COBOL program. This COBOL program is the code that manages the screen titles that I said I was going to change earlier. With the changes to the code made, let's quickly rebuild the application so I can test that they've been applied correctly. Now let's quickly check the application to see if my changes are working as intended. It looks like they were successful. In summary, let's consider some of the value of using dev containers. They can be used to provide local development environments that include everything you need to work on your source code. A dev container can be used for isolated testing and debugging. Sharing of the configuration inside the repo provides greater collaboration. New developers can be more productive quicker, as all the hard work of getting an environment set up is removed. You can integrate these dev containers into the CI/CD process to allow reuse of the dev container definition. The same source code may have multiple dev container specifications, allowing you to experiment with new technologies or later releases of your product. And lastly, dev containers are the basis of github.com codespaces, which I'll discuss in a later video.